thank you for coming. I didn't expect so many people to come. So it's almost the last session. So there is a sunny. We are in Barcelona, and you have chosen my session, which puts some extra pressure on me, actually. And the subject of the session is the hidden life of Spark jobs. We'll talk a lot about the Spark jobs. My name is Paweł Leszczyński, and the title of the session is inspired by the book The Hidden Life of Trees. It's the book written by the German forester Peter Wolleben, and the guy describes how do trees communicate. He claims how they have feelings, scent, and things like that. And I mean, it sounds a bit weird, but he relies on recent research on that topic. Yeah, so it's quite an interesting book. Yeah. And on everyday basis, I work for Allegra. I don't know how many of you are familiar with Allegra. I bet none. But I came here from Poland. If you are Polish, then you surely know Allegro, and it's a great probable chance you use Allegro. So Allegro is responsible for more than 60% of Polish e-commerce market. We sell 1 million products a day. We have like 220 million visits each month with more than 3.2 billion page views. At Allegro, I work in a data infrastructure team. We take care of Hadoop and Hadoop ecosystem. So I mean Hadoop, Kafka, the pipelines that ingest data from Kafka into Hadoop. Our architecture is based on microservices, so all the data is sent between the microservices, lands into Hadoop. We've got more than 6 petabytes of data on Hadoop, more than 22 terabytes of RAM on our Yarn cluster, and we do take care of Yarn resources. So what we do, we help others write their Spark jobs efficiently. We help them on everyday basis, look at their Spark jobs and check what can we improve. And yeah, we do it every day. When I go home, I spend time with my family, and when they go asleep, I read books. Yeah, that's why the title is like this. And at some point, I realized, spending 8 hours with Spark jobs, then reading some book about the trees, I have seen some things in common in forest, hugging trees guys and Spark jobs, and I was a bit frightened, so I thought it's sort of a mental disorder, and if you are afraid of a mental disorder, it's good to go somewhere and tell publicly about it, and that's why I responded to a call for papers, and that's why I'm here, and thank you for coming and helping me with that stuff. Yeah, we use Apache Spark a lot. Why do we use Apache Spark? Because almost any distributed processing problem can be solved with Spark. You can process data from HDFS, write data into HDFS. You can read data from JDBC, relational databases. You can write your processing in Scala, Java, Python, or even R. Actually, we use Spark a lot. We run more than 10,000 jobs a day. We've got about 10 versions of Spark on a cluster. So 2 weeks ago, we got rid of the last job written in 1.5. We still have 2 jobs in 1.6. Yeah, we want to kill them. And the majority of jobs is in 2.1.0, 2.2.1. And we have a deal with our clients that whenever a new Spark version is released, it's available on a cluster within 30 days. So last week we made available 2.3.3 because some people do need it. And of course we have 2.4.0. And the other part of the deal is that only 3 versions are supported. So if you are having some issues with old version of Spark, we don't help you. You need to upgrade first. Yes, so you can do almost anything with Spark. Our users use mostly Scala and Python. So if you are a machine learning guy, the big data developer, and your origin are development, then probably you will use Scala. and all the big data-driven products are made in Scala. But if you are a data scientist or an analyst, then probably Python is the best way for you to start, because if you are a data analyst and you want to learn a single programming language, or you know a single programming language, then it's surely rather a Python. Yeah, so actually there are more life forms in a handful forest soil than there are people on the planet, and the same applies to Spark jobs. There is a sort of a myth that PySpark is not that good as Scala. So written Spark jobs in PySpark is slower. It's yeah. And what does the PySpark do? So the PySpark does start two processes on a driver: the JVM Scala Spark process and the Python process, and it also starts two processes on each executor. And the problem is that if you want to process data in Python, you need to somehow exchange the data from JVM into a Python process. And these are two separate processes that communicate through pipe, and you need to deserialize the data, and it slows down a lot. Yeah, in some cases it slows down a lot, but in several cases it doesn't slow at all, because you may not need processing data in Python on the executor side. So I mean, you write your code in Python, you've got Python on a driver, but on a driver your Python code is only used just to orchestrate all the things that is done in JVM, in Spark and Scala. So Python isn't used for processing the data. And as long as you are using Spark API, so you mainly work with Spark SQL and the data frames, and you use the functions that are already available there, you're not processing data in Python. You just call from Python the Spark functions that do the data processing. And in that case, you don't lose any performance at all. Moreover, Spark functions are getting richer and richer with every release, so you can do almost anything with that. There are some few cases where you're gonna need to write some Python user-defined functions, and it's much easier to write a Spark job in Python, so you need 10 or 20 lines of code and you've got something working. In Scala you need to do a little bit more. There are two types of transformations in Spark. The narrow transformations are the low expensive ones, the low cost ones. So the narrow transformations, the example may be like filtering, given a single partition of data, the output of a task is a single partition. Yeah, so we may think of like, we get 1,000 records, we filter them, and we output some part of it. Yeah, it's relatively cheap. The more expensive thing are the wide transformations. So in that case, a single task needs to read a lot of data from different partitions. So it may be like group by, where the data needs to be sent between the executor. It's called shuffling, data exchange. It's expensive. It requires to send data across the network. And Spark Web UI is surely your friend. So it tells you what's going on with the job. It tells you the amount of active and dead executors. You can see there are 100 dead executors. Is it something wrong? We'll see the next slides. You can see the GC time. So Web UI colors it for you. If it's red, it means Spark spends too much time on garbage collection. You need to assign more memory or change something. The input, that's the interesting thing, because it tells you if you're really doing big data or you just think so, yeah? So it is possible, and it happens many times, that people are reading just 30 gigabytes of data and assign 100 gigabytes of RAM to the processing, because it's so important job to run, yeah? And here you can check it if it's really so. The shuffle size, so how many data is sent sent over the network, and the disk used. The disk used, if you do a lot of caching and cache doesn't fill into memory, it's spilled onto a disk. It slows your processing, but it doesn't have to mean anything wrong. So if your job fails at 2 a.m. and you go to your office and open your laptop at 9 a.m., then Spark History Server is your friend. So Spark Web UI lives only as the driver lives. Spark History Server allows you to see the Spark Web UIs of the job that are those jobs that are no longer running. Yes, so actually if a tree falls in a forest, there are other trees listening. Yeah, on the previous slide we have seen 100 dead executors, and it can mean there is something wrong with your job, but actually it doesn't have to. So as you can see here, an executor can get preempted. I don't know if you're familiar with Yarn, but let's say the Hadoop works in a way, you come to Yarn, say, hello, I would like to start a big job. And Yarn says, I have a lot of resources, now take as much as you wish, yeah? And you start a big job. And after a moment, the other guys are coming onto a cluster and consume resources. And then Yarn comes back to you and says, sorry, I need to kill some of your containers because I can no longer give you that much, yeah? And the executors get killed. It's possible that you get killed, an executor with some cache data, and even if you lose a tiny portion of cache, it may be necessary to reload all the processing from scratch. And actually, some users have a faulty assumption that the more resources I give to my Spark job, the quicker I will get the results. And it doesn't work that way, because you can get your containers preempted and you can start all the processing from scratch, and it will take way longer. Yeah, so you do a lot of mess on a cluster and you get the results later than without doing this. Yeah. Okay. The other interesting thing is the executor memory. So it's divided into 3 parts: the execution, storage, and overhead. The first 2 can be configured by Spark executor memory, the overhead by Spark executor memory overhead. And whenever you do some Python data processing and Python uses memory, it uses the memory overhead. And Python is not that good at controlling the amount of allocated memory. Yeah? So it needs memory, it takes more memory, and everything is within the Yarn container memory. So if you start an executor, you go to Yarn and say, please give me a container with 4 gigs. And Yarn says, okay. And then you do some Python processing and you exceed 4 gigs. You've got like 4.2 gigs of memory. And then Yarn says, oh, you're cheating on me, I kill you. Yeah, and kills the container. Yeah. And yeah, actually an organism that is too greedy and takes too much without anything in return destroys what it needs for life. Yeah. So you can get your containers preempted because you want to get too much resources, and it's difficult to control Python memory because you need to control both memory overhead and executor memory. If you do some heavy processing in Scala, so in Spark API, you need to add some memory here, and if you do also some Python processing, increase this one. And the popular issues we have are the driver issues. So the popular use case for us, for data scientists, is to do some heavy processing on a cluster and then play around with some pandas and numpy stuff locally. Which means people do collect data onto a driver. And It's possible, but you know, the good way to process data with Spark is to read data on executors and to write data from executors to the location you need. So data shouldn't touch driver, yeah. And if you collect too much data onto a driver, keep in mind about driver memory settings and max results, because you can easily kill the driver. So putting all the information together, Spark Web UI is your friend. If it's not available, then Spark History Server can help you. It can help you with answering the questions: what data is processed? How does the execution plan look like? You can see in a SQL tab. Are there any data SKUs? So you can see each tasks. How long did they take? You can check the yarn logs for the application logs, and you can also check the yarn internal logs, because it's the place where you find the information about the containers that got preempted and the containers that got killed because they exceeded the memory limit. Okay. It's something quite interesting we are dealing with. So people got crazy about schema inferring functionality in Spark. It's like, you know, it was charming for them. So you just write Spark read HDFS location and it works. You don't need to provide schema. Yeah, so people mostly use, in our case, Hive tables, so they don't have to provide schemas, but sometimes they want to work with JSON, because we still have some JSON. So we mainly have Parquet, some Avro, but still some datasets are written in JSON, yeah? And we had a problem that it looked out as if, you know, the schema inferring took twice as much time, you know. So we tried to debug this stuff, and it seemed like the Spark was reading the same data set twice, and we didn't know why. And of course, to debug Spark, it's good to download from GitHub the Apache Spark code, to open in some IDE, and to find out in a code what's going on. And we found some 3 lines. I think they get the sampling ratio. So, you know, Spark will gonna try to infer the schema from a sample of the data, and it needs to provide the sampling ratio. And it is looking for a sampling ratio parameter that our users weren't aware of, because perhaps it wasn't as good documented. And if it didn't found the sampling ratio, it returned 1. Which meant Spark was reading the whole data set just to figure out what's the schema, and then was reading it for the second time. It already knew the schema, yeah? And for our users, it was pretty cool, because they didn't need to you know, define the schema in front. The other extremely cool feature we had, and we still have, is dynamic resource allocation. So this looked as if you no longer need to take care of your resources. You just configure the minimal number of resources, the maximal number of resources, and Spark will take as much as it needs. Yeah, and for the analysts, a lot of people is like, wonderful. So I no longer need to, you know, count the number of executors, and it will be done automatically. Yes, it will be, except for some configuration arguments. Spark dynamic allocation cache executor idle timeout, that is default to infinity. So what happens? So let's see. Let's start some job, and dynamic resource allocation. The idea is that we define the initial number of executors, we define the minimal number of executors, and the maximal number of executors. And Spark starts with 2 executors, and at some point it realizes, okay, I will need to do some heavy processing. Let's start the other executors. Yeah, and it would love to start 10. so the other 8, but perhaps it starts 6. But it starts more executor because it needs more computing power. The heavy part of the processing is done, and then the Spark decides, thank you guys, it's been a great work, but you can go home from now, it's wonderful. And the executors say, hi, but we can't go home because we have some cache data. And yeah, and probably this is why the cache idle timeout setting comes and decides what to do. So we've got two options. So we either kill an executor with the cache data, which can mean in the worst case that actually we need to reprocess anything from scratch. We have lost all the things that we have computed so far. And this is the reason why the Spark community decided to give the default value to infinity, so that you don't kill the executor that has some cache data, because it may be extremely important. But the point is that with the value default to infinity, dynamic resource allocation doesn't work in a way you thought it, or at least we thought it will work. So imagine you have started a job and you said, when you need, just start 100 executors. And then for a moment you have 100 executors and each of them caches some tiny portion of data. And then you have like 3 hours of processing where you need only 2 executors, yeah? But Spark will not stop 98 executors because they do have some cached portion of data. So, so the behavior of Spark is quite logical, but it means dynamic resource allocation doesn't help you a lot. You still have to take care of the resources. It's not done automatically, yeah? So it's still the user who needs to be aware of his job and decide what to do. We had some job, quite an interesting one. It was written in Java, and it tried to solve, in Scala, sorry, it tried to solve a really interesting use case. So imagine we've got 2 data sets that are extremely big, dataset A and dataset B, and they store some user activities, the user activity events, and both data sets are daily partitioned, yeah? And as you may expect, we would like to join them. We would like to join elements of A with elements of B, and we would like to join 30 days of A and B. And we would like to take element of B and join it with element of A that happened before, and it was the last element of A that happened before for a specific user. And difference between timestamps of A and B can be up to 6 hours. And actually we need to join the elements from different partitions. So it's possible that one element occurs at 10 p.m., the other occurs the other day, and we would love to have them joined, yeah? And yeah, so the job was written quite well. So the idea to do is to use group by and co-group. So we can group by 2 data sets. We can group by dataset A and B, so that for each user we have the list of events the user has generated. And a co-group works in a way that we end up with users as the keys and 2 lists of the events for each user. And if we have something like this, we can create a list of all user events. We can sort that list, iterate through that list, and find out the join results. But it didn't work well. It was super slowly, and the ideal word would be to join a single day and somehow iterate over it. Yeah, joining in a single day is quite easy, because you just need 2 days of dataset A and join it with a single day of dataset B. And then iterate over it and simply increment x. This sounds quite simple, but the interesting observation of our idea is that we don't run 30 actions. So we create 30 transformations and run a single action afterwards. So if you run an action, then at the end of the actions there are just a few tasks processed, and even though you have 100 executors, you wait for the 5 tasks or something like this that need to finish. So for some time you wait for a couple of tasks and you don't process all the data at the same time, yeah? And if you do it 30 times, then you've got the 30 times you need to wait for the data. And if you do it like an iterative transformation with a single action, then whenever Spark ends a single day and encounters some slow tasks, it starts the tasks of the other day and it goes faster. Okay, so in that job we had 2 things that could have been rewritten. So we didn't need to infer the schema, and we have rewritten a join into an iteration of 30 daily transformations with a single action. And then we checked the results. We have checked it on 10 days of data. And before the job needed 50 executors to run. After that, it needed only 20. The execution time has been reduced from 98 minutes, almost 100 minutes, to 25 minutes. And it has used like 12 times less of yarn memories, megabytes seconds. Yeah. What does it mean? Yeah, so actually it means that Spark performance may vary a lot. So you may achieve a lot by trying to reconfigure things, by trying to rewrite your processing in a different way. And the bad thing is that you never know how good your job is. And you look at the job and actually you need to spend 4 hours, and either you improve its performance by an order of magnitude or you find nothing. But when you start, you don't know it, yeah? And there is no good way to know it. Perhaps if you write the next job on the same data size within your company, you know how big the data is and how shall it work. But you cannot, I don't know, perhaps you have, but I don't know any metrics or measures for that say you that your Spark job is 81% good. I don't know it, yeah? I would say that it's worth experimenting with the runtime parameters. So I used to say to some people that try to run your job with half of the executors and see what it turns to be. Yeah, because in many cases you don't find the difference. So it means people assign too many executors to the processing. The other thing is that perhaps it will run slower, but if you have less resources and you are within the soft limit of your yarn queue, then it's more sure that you will get the results. Yeah, and it's better for the cluster because you don't have a peaks, but the load is stable over time. So many questions remain unanswered. I don't know if it isn't a sort of a mystery. So at the end, it's just a Turing machine, a couple of Turing machines. So we've got a tape, a reader, we move right or left, and it seems like it should be simple, yeah. But actually, it's not simple, and it's quite difficult to understand what happens within a Spark processing, and what can you do with that. So perhaps we are poorer for having lost the possible explanation, but perhaps we are richer for having gained a mystery. Hard to say. Thank you. Please come with questions. Yes, could you use the microphone? Because the guy in the corner asked me to, you know, I don't know what he was really tall and strong.
What to do with a very slow writes on HDFS?
Right?
Spark and result, yeah. Spark result,
Yeah.
very slow on
Very
HDFS.
slow. Okay, you know, how much partitions do you have? Because if you have like, you know, if your data set is like 100 partitions.
Between 100 to 1000.
Okay, because the first thing that could be wrong, your data is partitions into thousands of partitions, then you write thousands of Spark jobs, then it's slowly, yeah? 100 to 1000. Then
May vary from 100 to 1000.
Okay. What format do you write?
We try to use 10 partitions and one partition result not good.
Okay. What format? Because, you know, if you write in Parquet, you need to create sort of an indexes.
This is Spark RDD and geocoordinates. Like JSON. This is JSON.
Okay. Why don't you save it into a Parquet?
Try.
I mean, if you have RDD, you can easily create a data frame based on it. You just need RDD and a schema. And once you have Parquet, then
if
you know all the other guys in the future that will read the data will have easier life.
We try the packet.
Yeah, but anyway, I don't know any reason why it is so slow. Yeah. Yes, please.
What would you, from your experience, what would you say that the size of the data file to ingest would be the optimal? And did you find a substantial difference in performance while reading Avro, Parquet, or other formats?
Yeah, so I would say the data file size should be less than a block size, so less than, I don't know, 255 megabytes perhaps. You said Avro and Parquet, so I would say Parquet is better because it's better than for reading, yeah? So we use Avro because you cannot have Parquet on Kafka. If you're using from Kafka, you don't, you know, these are just tiny files. There's no need to create columnar format based on tiny files. And we use Avro because data is in Avro. So Avro is not only file format, but also the binary format, yeah. And so if you ask, is Parquet better than ORC, then actually it's a funny question. You should ask the Cloudera guys, because before the merge they had different opinions, I believe. Yeah, so to the answer to that question, I don't know the reasons, the differences between ORC and Parquet, because it's quite similar. But anyways, I would recommend any columnar format. Yeah, I think you had a question. Yes, please, because the guy is looking at us. Yeah, yeah. He smiles, but I wouldn't trust him.
My question is also related to Parquet.
Sorry, I can hear.
To Parquet, we have seen we've had an issue last week that there were some files which were created, some tables which were created by Spark job, and they had the Parquet format. After we moved to another environment, we moved the files with this CP and recreated the tables through Hive CLI, again in Parquet format. When the job ran, it was complaining that the table is not in Parquet format, but it has Hive format, which doesn't even exist. I don't know what it is. Do you have some experience in that?
So not that specific case, but we had some issue that there are differences in Hive libraries and Spark libraries. So it might be like different Parquet version, yeah?
Okay.
But we had some issues with Avro file format in that case, not in Parquet.
And I also had a second question.
Yeah.
When we're running also Spark jobs in cluster mode, the exit code is not is always 0, even if the job fails, because we start a shell script, that starts a Python job, and that starts.
You mean the exit code of the Spark submit command?
Yeah.
Okay. So depends on how you schedule. So yeah, as you say, if you say it's 0, then it's 0. Yeah, we use Airflow for scheduling, and Airflow detects that something was wrong.
Okay, because when we it's exactly the scheduling issue, we get a success back because the exit code is 0, but the job actually fails. And when you look at YAR
So
logs.
we use Airflow, we use some Spark operator for Airflow, but I don't remember how it works. Perhaps it doesn't check for the exit code. It checks because, it submits a job and then checks the status on a yarn every couple of seconds, yeah? And perhaps the Airflow returns the value.
So Airflow could help us.
Yeah, I mean in Airflow it works.
Exception?
Sorry?
Are you sure it's not catching an exception? Because you should get error messages.
We get error messages, but the exit code, that's what's supposed to be not 0 if it fails. That's
Yeah.
always 0.
Even, and you're not trying catching it, you're not doing an exception somewhere?
Now we are trying to read the final status from YAR logs.
Thank you.
Airflow also, and it works.
Yeah, perhaps the Airflow operator works in a different way. Yes, could you please use the microphone? There are two guys, but...
Hi, thanks for your talk. I have one question. Do you have any sanity checks for monitoring Spark streaming jobs? Because then you don't have this, you can use the Spark history server or the Spark UI, but I think you only see the statistics for the first batch.
So actually, I'm not the guy that dealt with Spark streaming. We've got only one Spark streaming application. It's the job written in 1.6, and yeah, we don't use Spark for streaming. And actually, I was trying to do, the ingestion from Kafka to HDFS, and I tried to use a Goblin from LinkedIn. So I don't have any Spark streaming experience.
I have a question, but before that I want to give two quick ideas for you for a slow HDFS write. It's very important to not give more than 4 cores per executor because you get into a bottleneck of writing. So in general, more than 5. Yes. So I always use 5 cores in my executors. And the guy who asked about the exit code, something I did, I'm using the Spark Launcher API in Java to have a Spark, to have a wrapper for the Spark submit. And then there's a stream output which I also read, and then you can notice if there's a successful or a failure or exception, and you can do whatever you want with it. And then you can create your own exit code and not just rely on the Spark submit exit code. So having a wrapper might help. And for you, I'm just interested that in this lecture you talked a lot about people preemption and limiting your resources. But I'm interested why your users need to use more than the queue you are giving them.
Why do they need more?
Your users probably have a yarn queue dedicated for them. So what makes them have? Why do they need, if they have like a yarn queue of 20 executors and X gigabyte, what makes them suddenly need more than that?
Okay, so I think some of their workloads cannot fit into soft limits, so they exceed it. And it's like nobody writes inefficient code. It's like it's a process. Someone is asked to do a daily processing. He does a daily processing. After a quarter, the business changes. Let's process 10 days within the same job, yeah? And then someone says, okay, we've got some emergency situation. We need to process 6 times the whole month, yeah? And that's how you end up with the jobs that are not efficient, yeah? I don't know if it answers your questions, yeah? But
it just seems to me that except trying to handle your executors and whatever, like it makes more sense for them to ask for the queue to get bigger and always limit themselves to the queue.
Yeah, but we are running on-premise cluster, perhaps. It's something I didn't tell. So if you want bigger soft limits, we need to add the machines. So the amount of the soft limits needs to equal to the cluster size, yeah? So if you say that we want to exceed the soft limits, we have to increase the soft limits, we need to buy the machines. Yeah, that's why we try to have the soft limits low. And on the other hand, there's nothing wrong in exceeding the soft limit. Yeah, because if the resources are empty, then please come with your job and let's process it. Yeah. The problem starts if the other guys are coming and you need to decrease your resources into the soft limit.
I just had a lot of issues with preemption, so I always try
Okay,
to stay
okay,
on the side.
thank you. Yes,
What about the compression? You use compression?
compression of,
Compression of files?
yeah, we use Snappy. With Snappy you can, perhaps you use Snappy with, the compression set to 10 and then it's no, we use, I don't know, 6 or 7, yeah, but
6 or 7.
yeah, because you can, if it's 10, then perhaps it's slow because of 10, yeah? Okay. So, thank you for coming, so many of you.